Okay. A unity feedback system is given as this. Now we need to draw the root locus diagram. Okay. Now notice that there is a negative sign on the S, right? So we need to make this as positive here. Okay, so now we have the transfer function. And the gain is minus k here, right? So it's a negative term. So all our rules, right, were prepared keeping in mind that the k is a positive term, the gain, right? And it goes from 0 to infinity. Now here, as the k goes from 0 to infinity, there's a negative term. It becomes from 0 to minus infinity, right? So what happens to all these rules? So the rule remains same, except whenever there is an odd, it becomes even, right? So the one which I have highlighted in blue will change. So the rule 3, which said that there has to be odd for a point in the real axis to be lying in root locus, it should have odd number of poles and zeros to the right of it, right? So now that will become even. So that definition will change to even. Again, here in rule 4, it said the asymptotes, right? It should be odd multiple of 180 divided by the poles minus zeros, right? So that will again become even multiple of 180. Whereas, yeah, in rule 7, same thing, even multiple of 180, right? So this will become 2p. Rest all the rules remain same. So let's solve for this now. So we have 1 0 at the right hand side, 1 pole in the 0, and then there's 3, right? We know. Okay, now the rules, since the rules have changed, right, this will be lying in the root locus because even number of poles and zeros, this will not be lying on that, obviously. So k goes from 0 to infinity. We start from the open loop poles, and we should eventually end up at 0, right? Again, this line will be lying in the root locus. Why? Because even number of, right, 0 is also considered even. So somehow we will be reaching here. Okay, and there is 2 poles and 1 0. So 1 0 should be assumed at infinity, and that will be obviously this one, right? Because since this whole line is lying in the root locus, so another 0 is at here, right? Now we need to connect this. So somehow this will be connected, okay, like this. Okay. So if you see this option in the MCQ, you can solve it directly. But now there could be confusing option where they can give you the intersection points also, right? Multiple options has different value for this intersection point, or also the breakaway and break-in points, right? Those can also be given as a confusing options in the MCQ. So breakaway, break-in points we have already solved in previous problem. Use this rule to solve for it. Okay, what I will focus on this problem is the finding the intersection point with the j omega axis, because we have not used rule 8 yet. So let's use that rule. Okay, so where does it intersect? Again, let's write the characteristic equation. Characteristic equation will be 1 plus, it's a unity feedback system, so 1 plus j is equal to 0 because h is anyway 1. So if you solve for this, then it will become s square plus 3s plus k 1 minus s equals to 0, right? Again, putting all the powers together. Okay, so this is the equation, characteristic equation. Now to solve for this, the intersection point, we need to apply the route criteria. We had learned this, the route criteria, how to solve for it. So s square terms, we take alternative terms 1 k. S would be 3 minus k. Okay, and the first term would be again this into this minus this divided by this, so it will ultimately be k. Okay. Now, in order for this root locus to intersect here, this coefficient has to be 0. If this coefficient is 0, then you will get the auxiliary equation just above that. And we know that from the route criteria that once you solve for the auxiliary equation, you get the roots which lie on the j omega axis, right? So if you make this 0, means what? K is 3 now. So this becomes 0. So that's right. So basically s is plus minus j root. So this is j root 3 minus j root 3. These are the j omega intersection point. Yeah. So we use this rule as well. So we have so far used, I think, all the rules, right? In our 4 problems, we have used all the rules, right?